Let's just get things started for everyone here today. So welcome everyone. Thank you so much for joining us today for our EaaSI webinar in our latest in our ongoing series. My name is Ethan Gates. I'm the software preservation analyst here at Yale University. For those who aren't aware at this point, Yale University is the host to the EaaSI program of work. And today we are talking about the EaaSI metadata model. It's going to be a roundtable discussion between Michael Olson, Seth Anderson, and myself. Just a little housekeeping before we get started on the technical side. If you have any questions during this presentation, please type them into the chat box in your Zoom control panel. Jessica Meyerson is going to be hanging out in the background watching that chat, especially so that she can be sure to gather up your questions and bring them to me, so that we'll have some time for a Q&A at the end, and we'll be sure to address those. If you can also, please try to mute yourself and turn your video off if you haven't at this point already, just to help us maximize the quality of the recording. All the webinar recordings for the EaaSI webinar series are going to be made available on the EaaSI website with transcripts once the series wraps up. So now I'm going to introduce our guest speakers and members of the EaaSI network for today's presentation. First up, we got Michael Olson. Michael is the service manager for the Born Digital Forensics Lab at Stanford Libraries. He works with librarians, faculty, donors, and archivists to develop policies, workflows, and procedures to acquire, preserve, and make Born Digital content available for researchers. Everything comes in threes for Michael. He is currently responsible for the implementation of forensic tools and library workflows, defining security policies and audit processes for acquired content, and automating processes for depositing preserved software into the Stanford Digital Repository. Michael has an MPhil in History and Computing from the University of Glasgow and a BA in Medieval Studies from the University of British Columbia. I did not know that, Michael. We're going to have to talk about that at some point. Our EaaSI staff lead for today is Seth Anderson. And again, Seth is the Software Preservation Program Manager at Yale University Library, where he oversees efforts in collection and preservation of software resources, as well as tools for access to preserved software and digital collections. Seth received his master's in moving image archiving and preservation from New York University, and he has previously worked as project manager of the Museum of Modern Art's Electronic Records Archive project, and worked with Carnegie Hall, the Smithsonian Institution, and the United States Holocaust Memorial Museum as consultant with AVP. With no further ado, it gives me great pleasure to hand it over to Seth for an overview of the EaaSI metadata model and the role of Wikidata in the EaaSI metadata universe. And it is a universe, like a galaxy. I've seen the graphs. So take it away, Seth.
Thank you, Ethan. I appreciate the great pleasure. All right, really quick, let me share my screen. And let's go full screen. All right, so greetings, everyone. Thanks for attending our webinar. And if you've attended in the past, or even if this is your first one, welcome. We're happy to have you. So yeah, I'm here today to talk about the metadata model that we'll be applying in the EaaSI software that will be implemented in upcoming updates to the front end of the system. And if you've attended any of the webinars in the past or have seen us talk about the project previously, you'll remember that one of the main pillars of the project is to take a look at the descriptive practices for software and preserved software, as well as computing environments, in order to improve and expand upon mechanisms and best practices for describing these items that we work with so much in the EaaSI system. And so for our purposes, we collect metadata for a number of different reasons. Of course, we are collecting metadata to improve discovery. So as we add more and more resources to the EaaSI system and to the EaaSI network that is shared, the resources that are shared between the nodes, we want to make sure that they're easy to find and that you can perform simple keyword searches and find a software application that you need to render a file that you have, or to find an environment that already has that software installed, or an environment that could serve as the basis for new software installations, etc. We also, of course, want to track all of the resources that are going into the EaaSI system and into the EaaSI network. So making sure that we're documenting kind of what I would call the provenance of where these things are coming from and where they're going, so that over time and for digital preservation purposes or for auditing or reporting, we have the information that we need. We're also, of course, collecting information just to administer the system in general. So making sure we have the necessary information for tracking or knowing what users are up to, knowing what resources are in and out of the network, what is and isn't deleted, all of those details that go in with running a system like this are getting poured into the model. And then finally, and I think this is the biggest and most challenging piece of developing and implementing the model, is that we're looking at ways of using the metadata that we do capture as a means to automate certain workflows. And the goal with the EaaSI system is yes, to provide easy access to emulators so that you can configure them and use them in your workflows. But we also want to make it as easy as possible, no pun intended, to get from point A to point B. So instead of requiring a user to always do the legwork, we want to see how we can use the metadata that we capture to move us from, say, having a file and getting to the software that we need as quickly and easily as possible. So with all of that said, all right, I'm going to ignore the chat. What is in the model? There's a lot, but I want to start by taking a step back to just talk about, of course, what it is that we're emulating and how that applies to metadata. So, right, if we are looking to recreate a physical computing environment virtually in our software, and so if you think about a physical computer, either the one in front of you or one that you had in the past, any computer you can think of, there are a number of different components that all intertwine to create this computing environment that we interact with through the tools and with EaaSI through our browser. So you might have a monitor, you have a mouse, you have the processor, different cards that can manage the visual capabilities of the computer, the audio capabilities, the networking capabilities, etc. You then, of course, have the bootable elements of the computer, so the disk within the environment that contains a bootable system, which would be the operating system and all of the various component parts of that. And then, of course, you have the additional elements that store data that needs to be interacted with through this system. So you might have floppy disks, optical disks like CD-ROM or DVDs, and then other versions of hard disk storage, so external drives, USB drives, et cetera, et cetera. And of course, we are looking to emulate those, and so those get reinterpreted as, for the hardware piece, an emulator software configuration, so telling the emulation software what devices to emulate and how to construct them in this virtual computer. You have a bootable system, so you have a disk image that contains all of this information that then is retrieved by the emulator. And then all of those additional storage and software content items that get loaded into the computer, which again are disk images. And so in this model, we have to describe all of these pieces, both as kind of conceptual elements and their sort of applied version. And so if you think about this, the scale gets quite big because you're often duplicating information and then connecting all of them through relationships is a challenge, but interesting in my time. So about a year ago, probably about 6 months into the project, in June of 2018, we began sketching out what this model would look like as we started to realize that there were a lot of complexities and details that we needed to start capturing in order to achieve some of the goals that we had. And so we looked at existing schema and some of the great work that's been done by others in the community. One in particular being the Totem project. And while we haven't used it as a basis, these projects inform, of course, our approach. But we've also looked at the GameSip project out of that was at Stanford, I believe, as well as some of the crosswalking work that was done by one of the working groups of Software Preservation Network. And then, of course, we have a team member, part of the EaaSI project team, Kat Thornton, who has started this Wikidata for Digital Preservation project, which preceded the EaaSI project. And she's done a lot to define models for describing software versions and file formats with the goal of using those within Wikidata, and we're intending to recreate those within our model so that we can exchange information. I'll talk about that in a little bit. So I'm not going to dive into the nitty-gritty details of the model. I will show you what it currently looks like in my modeling software. And this may be an indictment of my ability to build a database, or might just give you an idea of how complex this all is. But if you boil it down to the simple details, it essentially tracks across the types of resources that we use in the system. So we have software objects being the operating systems, applications, drivers, et cetera, that are applied in some way in computing environments or emulated environments. We have those environments which we describe. And then we have content objects which can be joined with computing environments for rendering and access. And I'm going to quickly, because I know that I'm going to run over time, move through these. So we break down software generally. We adopted an existing Ferber-based hierarchy for describing software, and are applying it in our model. And it essentially moves from the 4 tiers of Ferber. So you have a work, expression, manifestation, and item. In order to separate out various attributes of a software application from its kind of highest level conceptual instance to its lowest level kind of applied and distributed instance. So in the system, we have this concept of the software product, which is kind of the high-level grouping of specific software releases. So you can think of Microsoft Word, Adobe Photoshop, LibreOffice, or something like that. Those are then expressed as versions. So all of those, right? Microsoft Word has Word 2000, Word 97, and so on and so forth. Those are then manifested as either an object, so that would be in the physical comparison, the installation media, the disk, the CD-ROM floppy disk, et cetera, required to install those items. Those could also just be files that are needed to compile and run that software version. And then once installed, we have this manifestation of that version as a configured piece of software within an environment. And then the lowest level, of course, being all of the various instances of those software objects or configured software within the EaaSI network. So, of course, there will be one item at Yale and maybe another one at Stanford and so on and so forth. And so if you look at this, I ran out of room to include the item, but if you think about this from, like, just as an example, you have AutoCAD at the top level, AutoCAD 2000 as a version or expression, and then you have the installation disk as a manifestation. And again, once installed, it is a manifestation as well of the same software version. And so this way we can structure the software so that it inherits necessary information and can kind of compile all of that to display it to the end user in a sort of convenient and user-friendly way. So I have some definitions here, which may not be as helpful, but I do want to give some example. Whoops. Jessica or Ethan, remind me when I'm running low on time.
I want to give you. I want to bring our discussion around at around 11:20. So if if you can,
right. I'm gonna
wrap this in a few minutes.
All right. So an environment is a combination then of a collection of installed software, so an operating system and a software application, and a configured machine. So a defined set of values that are related to the actual hardware of the computer that's being emulated. And then once you combine all of those in the emulator software, that is what we consider a computing environment. Are we having audio issues? Okay. And these slides will all be shared, of course. So, and I'll also be sharing the document, the spreadsheet that has all the definitions of the metadata model. So that would also be available. So finally, the last kind of conceptual area, of course, is the object, or what we're now kind of calling a content environment. And that's like very simply just the connection of a file or content object that's been added to the node and an existing computing environment so that it can be rendered. So it's like just a simple connection between the two. So I will fly through this, but just to give you, and we'll talk about this a little bit later, but we're doing a lot of legwork up front to populate the system. One of the things that we're trying to avoid is user fatigue. So instead of requiring everyone to key in a lot of information, we want to pre-populate that information so that you can have drop-downs and visual cues for selecting the settings that you've defined in your computing environment. So in one way that we're doing that is we're pulling data that already exists from the Wikidata knowledge base and using those as control value sets within the database. So for things that are relatively static, like CPU architectures, file formats, keyboard layouts, etc., we're pulling that information in and we'll periodically update it with new information that Kat Thornton will be providing us and populating the databases and the other databases in the network to have that information to apply. Also doing some upfront research to define, for instance, what settings are available within the various different operating systems that we have in the network, what software applications support specific formats, so defining in a structure those elements, like how they define them and what formats those are tied to, what hardware and emulator can actually recreate, and defining that within a structured data set, and also structuring system requirements from the applications that we are loading in from Yale's side. And finally, just some data capture methods. So if you haven't checked out the Wikidata for Digital Preservation portal, this is one mechanism for adding information about software and file formats to Wikidata. We will be encouraging the users of EaaSI to use this to update information about software. Once it's been published to the network, there are some rules that we'll be applying just for quality control. But we want to push folks to use this portal because of the great work that Kat's been doing. But we will, of course, also have some editing modes for the new UI to update information about software and environments that have been configured in an EaaSI node. And we're also working on serialization of the metadata that we capture, both for exchange between the nodes, but also as a means of submitting or importing data into an EaaSI infrastructure without having to do any like data entry or filling out all of the various forms that we'll have in the system. So trying to speed up and that's time, Jessica says. So challenges, I've got one more. I think this is the last one. Controlling data quality, of course. Big one is the structural differences between operating systems, computer platforms, so the different ways that different computers and computing environments actually use information or structure information makes it really hard to kind of create a universal model for all computer types, and especially as we get to older computers, these things change a lot. Domain-specific metadata about software applications and how they're used, and making this easy for users. So I've gone over time, so please ask questions. There's plenty to share.
Yes, awesome. Thank you so much for the overview, Seth. As he mentioned, please, like, if any questions are already coming up from the group from that overview, I mean, please just put them in the Zoom chat. We'll be sure to try and get to them in the Q&A session at the end here. But right now, I do want to transition into our moderated discussion with Seth and bring in our node host, Michael Olson, so that we can ground some of this, high-level conceptual overview that Seth is talking about in everyday practice at Stanford and at Yale. So first off, I do want to just directly bring Michael in. If you could talk about how do you at Stanford, create, manage, and discover metadata about software and related resources right now? What is your state in terms of implementing the concepts that Seth has been discussing?
Hi, everyone. Just give me 1 second here. I'm actually going to share my screen. Good morning, everyone. Thanks, Ethan. Thank you, Seth. I just wanted to transition a little bit. This is a little bit of old data that we have from a disk imaging software preservation project that we ran roughly 4 years ago. It's a spreadsheet, surprise, surprise, but a pretty masterful one that was actually created by our metadata department and our Arcadia Falcone, amongst others. But as you can see, there's literally, we have genres, and there are over 8,000 lines, and this is just one collection. So our metadata creation process currently, as it currently stands for software, and this is primarily because a lot of our software actually comes in through a special collections workflow as opposed to just a regular cataloging workflow. We do receive some software there, but the huge sum of it probably comes through a special collections workflow. So we haven't in the past necessarily done item level metadata on all the software we receive. We do it for some, but this is how we've been capturing our data for the Cabernet project. And it's a lot of data, but as you can see here, we've been trying to figure out, we have genres. This is a lot of the publisher data, and then if I can find this here real quick, we have manufacturer data. I'm sorry if I'm making everybody sick, but I thought giving some really good examples here and then more importantly, we have operating systems that you can start to see here. So our workflow up prior to emulation as a service coming online has been primarily to capture our descriptive metadata for software in a spreadsheet. That's what it looks like when we create it. Then of course we've had this whole process of importing our descriptive metadata along with the digital objects that we're preserving into our digital repository. So this is the view of what some of these titles look like actually in our repository. What we're missing right now is a way of actually delivering a lot of these contents directly from our catalog. And that's where we're really hoping that that the EaaSI emulation as a service can really sort of help us actually be able to embed just a identifying string in the catalog record, and then would take some folks to directly to the actual software running in its environment. So we've got a lot of questions about how do we go from some of these systems that you're seeing here into the EaaSI environment, and Seth has kind of started to talk a little bit about some of the different how we're envisioning this going forward as the work evolves and develops over time. But this is just kind of a little bit of context. We're not starting with nothing that's cataloged. We're kind of hitting it mid-flow, and we have lots of questions and challenges to work out with our other node hosts and with all of you to figure out, you know, what are some different workflows for actually streamlining and getting content that's already described in Wikidata and into the emulation as a service environment. So I'll stop there. I don't want to take too much time for folks, but
yeah, no, thanks, Michael. That's a great. I think you've brought up a really great point here in sort of like the interplay between EaaSI and local descriptive practices that might already exist. And particularly looking out at the data you were sharing, you know, to me, like the source and sort of like ID fields stood out because this is a challenge that I know we've had working with EaaSI at our Yale node around naming conventions, because EaaSI from a technical, you know, backend perspective basically assigns a unique identifier to every saved and configured emulated environment. It assigns them to individual disk images and associated software objects. Just so from a backend perspective, all EaaSI needs is these UUIDs, universal unique identifiers, in order to assemble the pieces it needs and move them around. But that obviously is not very friendly on the human end in terms of finding and discoverability. So I'm curious how, I mean, both Michael and Seth, you see this moving forward, whether it's in the new UI work. How do we make it so that, you know, when we're talking about pieces of software or configured emulated environments that potentially have extremely small differences between them, we can gather all the metadata we want, but how do we define and surface those differences and make them discoverable, the particular objects that you know, students or scholars are actually going to want to see findable to them? If anyone has an immediate thought on that and just wants to jump in.
Yeah, it's a question that we struggle with a lot, especially, I mean, I think I've titled previous talks around kind of what are the significant properties of a computing environment, and what do we need to record that is useful to a user? Because I think what we've focused on a lot is what's actually useful to the system. Which, given the kind of parameters of our project, makes a lot of sense. And I think we won't really know until we see more use of the data model in the system and kind of surface what it is that users actually need to know to find computing environments and software objects. We're also looking at, I mean, we've been working with Portal Media out of Madison, Wisconsin, who's the developers who are designing and implementing this new front end. And we've talked about ways of kind of providing visual comparisons of environments. And once we have more information about the environments, we could, I think, potentially, you know, guide users a little more effectively in saying, hey, the thing that you're just about to create probably already exists. Is it, is this the environment you're looking for? And kind of surfacing ways that we can provide a more guided experience. It's a little challenging now with the kind of lack of overall information that we have already collected.
Yeah, Michael, where does the identifier system you were using come from exactly, and how successful has that been with integrating with your catalog systems?
It's been, apologies, I was just booting something up there in the background. It's been, we're making what we think are educated guesses as we're going with how we would construct identifiers and things like that. The obvious ones that most librarians are aware of in preservation circles, like no spaces and file names and that sort of thing. I think the real challenge is not only with figuring out how we're going to interoperate with these multiple systems, but I'm going to share something really quickly, just because this might actually spark some additional discussion at some point. And that's, we're not just talking about the executable software running in an environment. There's all the paratextual materials that actually go with it as well. So I'm going to show you what that looks like for just one example. So you can see here, this is actually a CD-ROM collection from the IMF. So, it dates from the early 2000s, roughly, late 90s, early 2000s. But there's all this associated data that comes with it that we're not, we think we know how researchers are going to actually access this and actually use it, but it's a little bit difficult. And this is maybe not, this is a very specific example. You can imagine things like video games where there's a lot of box covers and associated documentation that comes with it and fan stuff. So that's definitely one of the challenges, is how do we actually integrate this sort of material into delivery environment, or make it available? How much work does it actually take to do that? And more importantly, who's responsible for it? We're actually really hopeful that we can push some of this work in the Wikidata and the emulation as a service environment up to the librarians who have a little bit closer to the actual researchers, so they can help make those decisions.
Did you have a thought there, Seth? Or
I was trying to piece it together in my head. Just looking at those items, the interesting piece here, right, is that those already have existing identifiers. They belong to another system probably. And so one of the challenges, again, that we're facing as well is just thinking about interoperability. And we have some plans in preparation in the model right now to digest, local identifiers so that you can connect, this object from your collection to the virtual version in EaaSI. But that's still a somewhat tenuous relationship because they're currently completely separate systems. And so I think one thing that we'll be looking into coming down the road is just how to more tightly connect these two existing systems. We've already done it in one instance with Yale's Preservica repository, so that a lot of these questions around, like, how do you identify and manage all of this different information can be tied into existing structures and infrastructure at all the various institutions who are using EaaSI.
Yeah, drawing off of both of those points, I'm really interested because, Michael, you're bringing in the question of like paratextual sources and where we source all our metadata from, speaks to the possible convenience and real advantage of using Wikidata in terms of centralizing some of this, often like a lot of this information exists, but is just scattered across many places, whether it's local catalogs, the internet, et cetera, physical objects. So that, again, speaks to the building of a communal resource, but then, Seth, as you're saying, there is this interplay between possibly locally unique information and EaaSI itself having its own peculiarities within that metadata model that you demonstrated that may not be, that are very important for, building an easy database and discoverability within an easy system, but may not play with or be, may not justify inclusion in an external database like Wikidata, especially when we're talking about derivative, environments, again, with these possible minor changes. Can you think of strategies for, like, how do we address this within the wider community, and how do we raise awareness for the need for these small changes, within EaaSI, while being flexible for local changes? It's a big question.
Yeah, I think, our hope is that by tying EaaSI, not tying, but coordinating EaaSI, I guess, I don't know what the best way to put it would be, with the Wikidata and Wikidata for Digital Preservation project, that it also serves as kind of an advocacy element to this. So we want not just EaaSI users to supply information to Wikidata, but anyone to, if you have information about software, use the WikiDP portal to put it into Wikidata so that we can reuse it, and vice versa. I think we are really hoping that we can act as valuable or instrumental members of the Wikidata community by providing the information that we gather in EaaSI back out to Wikidata, and create this interchange that would be valuable to both of us. But yeah, I think our hope is that by gathering more and more information, that we kind of raise more awareness of the need to document these things, focus the community on pursuing better practices and best practices for documentation of these items.
Yeah, I want to push to Michael, because I'm wondering if there are strategies or like lessons learned from starting to gather the metadata that you have in the first place. Surely that was a point that had to come up at Stanford. Is there anything we can take from those sort of local processes and apply to the network within the larger community?
Yeah, that's a great question. I think one of I'll back up just really quickly. A lot of the data that you actually saw is actually going to end up in Wikidata, kind of through a circuitous route. So, we're, I think there definitely is a desire on the behalf of the different nodes that are a part of kind of this initial rollout for EaaSI to try and populate as much of their content as possible into the Wikidata, just to be able to make it available to the community so people can react to it and interact with it. I think that's really key. The other thing is, I think going forward, we're definitely we were talking kind of a little bit about legacy collections and things that we've already sort of had a processing path for. And I think going forward, we've definitely got a bunch of different collections queued up where we're going to try to figure out what the workflow looks like natively, for actually creating the metadata and Wikidata and that sort of thing. So that's about as far as I can think right now. But thank goodness we have lots of brains on the call that can help. So
yeah, we'll definitely be continuing to crowdsource this discussion.
Yeah.
But yeah, I wonder if Seth, you could build a little bit more on, you were sort of implying the value that this metadata might have to the wider community as we build WikiDP. I mean, what is the value possibly to the community, the digital preservation community, beyond building out EaaSI, in terms of the metadata you're looking at in the model?
Well, I think, if you look at emulation as an access mechanism for preserved collections, for digital collections, if we get EaaSI, if we have representation information, which would be the software that's required to render these materials. The more information we have about that software means that we have kind of better digital preservation packages about our digital collections. So by consolidating and structuring that information, we can apply it not just in EaaSI, but across other programs and systems, so that there's kind of a second order value to all of this. And we're not just creating another silo, I think is the general goal.
Yeah, and building on that point, I would also want to bring up the work of our summer intern, Claire Fox, who was with the program. She's also from New York University's Moving Image Archiving Preservation Program. And if people on the call want to check out her blog post about the work she did over the summer, preparing like what a preservation package from EaaSI would actually look like in terms of like exporting out data so it could be reused in other systems in combination with the metadata that Seth is talking about. That's a really fascinating post that's worth looking at in terms of this discussion.
Yeah, if I can
also
just jump in and make one really quick comment. I mean, one thing that's really obvious, even with the IMF, the International Monetary Fund CD-ROMs that we're talking about, is we were actually able to some of the work that was previously in the system that was provided by the Yale node was something we could leverage to actually make that available. So, you know, there is value in creating base environments and for making that, describing that and making that available through just, you know, description and Wikidata and stuff like that. But there's already value there, just because there's base environments that we can grab and actually see if it works.
Yeah, and I think, you know, that the underlying, I keep saying the underlying goals, but we have a lot of them, of course, is kind of this community approach to software collection. And that's a perfect example of how the metadata that we've captured or the software that we've already configured has been of use at Stanford. And before we move on to Q&A from the Yale end, I would just want to point out that so much of the information that we've already captured and that will be populating the system soon-ish would not exist without the great work of our student software configuration workers. So all of those fields that we've been preparing in the model, students have already been using that model as a means of capturing information as they go about installing and setting up the software in the Yale's EaaSI node. And it's not trivial, as Klaus would say. And they've done a really great job, and yeah, we really appreciate them, and we are thrilled that we have many new students joining our team this semester.
Yeah, and I'll definitely be diving a little bit more into their work next month for the configuration webinar, because their work will come up there as well. But yeah, our students who run the gamut from freshmen to master's grad students have all been fantastic. Yeah, I think that's a great point for us to transition into our question and answer period from the audience. We've already had a great discussion going on in the chat here that I want to bring in. So Cindy asks, what was the decision factor for choosing Wikidata and WikiDP over Pronom, the Pronom registry, considering especially that premise, the preservation metadata schema that's fairly widely adopted really pushes Pronom. And we had a response from David Underdown that I think probably covers some of it, saying that a lot of what's needed for EaaSI goes beyond the existing Pronom data model. But yeah, I think that's true. And Seth, maybe you want to talk about that specifically.
Yeah, so I wouldn't consider it an either or question, because we do intend to incorporate Pronom IDs for file formats into the model. And essentially, I mean, the benefits of Wikidata over, is that Wikidata serves as to consolidate information like a pronom ID, as well as, say, a MIME type or any number of registry identifiers under one record for a file format or a software application, et cetera. So it still incorporates pronom, but it incorporates as well a number of other useful and valuable information points that can then we're linking all of this information. That's the idea. So that's why going with Wikidata.
Great. Thanks, Seth. It's pretty straightforward. I don't know if Michael has anything to chime in. Otherwise, I'll just move on to the next question from Patricia. We've got, is EaaSI looking at custom-written software, for instance, artist software or scientific research software, and how would metadata, for those particular communities possibly be different? How could it fit into our model? That's also a great question.
So I think as glossed over this in the challenges slide, but domain-specific information is tricky, of course. And the challenge with creating the model for EaaSI was determining at this point, I mean, we may expand on it and extend it a bit for specific disciplines, but right now it's intended to be as universal as possible. So we also didn't want to step on the toes of other systems. So the focus of the model is what specifically is needed, one, to set up an emulation, but also what information is most useful, across the board, so universally, about software for discovery and fact finding. So it's not, we kind of always want to keep pushing that, like, EaaSI isn't your collection management system, so there may be a lot of information that exists in other systems that would be helpful to how you would set up an environment, but for our purposes, our primary focus is on, the simple information about the software, and then information about its functionality and its requirements.
Yeah, that's great. Michael, I'm curious, has this come up at Stanford in terms of gathering software metadata and, working with possibly domain, unit, department, even level specific metadata, people wanting to learn certain things for their own needs?
Yeah, definitely so. I mean, I can't speak specifically to the nitty-gritty details of each sort of potential use case for how software can be represented. But we've definitely been working, one of our efforts has been to try out as many different use cases as we possibly can using the existing EaaSI environment. So to give an example of something that's a little bit different, one is we're working with the university press here. So digital publications that tend to be, they exist just as digital publications, and the technology stack that these researchers are creating tend to be quite custom, and that presents some interesting challenges, particularly because the technology is moving so fast. We're also, some of the use cases that we're hoping to test out in the emulation as a service interface, and we're just really starting this work, is some of our use cases are research projects. So from the Center of Interdisciplinary Research here. So interesting things that some of our humanities professors are working on. And of course, we have scientific data sets as well. So that's a whole other challenge. So yeah, it's definitely something on our radar.
Yeah, I think it would be useful to describe the intention or the scope of the EaaSI system versus what will be access modules or access services built on top of what EaaSI generates. So I think like the primary system that we focus on daily here at Yale, and what we're actively working on and developing and upgrading the front end for, is a tool for staff at the library, at the university, whatever, to generate the emulation environments, which are then provided to an end user, patron, whatever, through another service. Now we're working on developing some of those sort of access oriented services, but they are separate, conceptually from EaaSI as a system, which is why if you look at the model, once they share the data, when it comes to the actual content object that's loaded in, so the disk images or files that are meant to be rendered in an emulation environment, we don't actually capture much information at all. So no descriptive information, just a name and the local identifier, and then maybe some technical information about the actual objects of the, what type of media was it originally? Is it a file set? Is it a CD-ROM, disk image, etc.? And then we would rely on, a catalog or a collection management system or some access system to provide the additional contextual information to the end user. That raises certain challenges we're trying to, of course, address, but that's the idea.
Yeah, it's really interesting, Seth. If I want to point out to the audience that we're sort of moving into our last few minutes here. So if there are any more questions, please put that into the chat, and we'll make sure to bring it up before we wrap up here. But this tension that is we're basically talking about between designing a system that works for many people but can be customizable to the few, I think is a really difficult one that is not unique to EaaSI. So trying to think how to frame that into a question that it's not just like boy, isn't what we do hard, but can let's see, we have let's see, I do want to point out for those who are maybe just listening in on the call that Jessica posted in the chat, point out that in a previous software preservation network quarterly forum, Patricia from the Tate, Dana Boyquin, Klaus from our team here at EaaSI talked about how at a certain level all use cases require the same metadata just to get these environments working, but then there is this additional level that Seth is talking about, the level of the software objects themselves or collection items, that these become local policy concerns. And this is another place to point out that while EaaSI manages creation of emulated software or of emulated environments and of software collections, we do emphasize that the system does not necessarily manage digital collection items and wasn't intended to. So how we can build a system that interoperates with digital repositories that are a little more set up to actually perform those duties and gather metadata about those kinds of objects is a really interesting question. Are there, what kind of systems and integrations would you like to see, perhaps, Michael, from EaaSI in terms of how EaaSI metadata interfacing with other systems or services that you use?
Yeah, it's really a challenge, and I mean, I think that's one of the challenges that we're working on right now, and that's why when we were standing up our EaaSI node and how we've kind of constructed our participation from the Stanford side of things has been, we want to pilot different collections that have different, they're a little bit of a different flavor, with the realization that not one system can do everything, and that it's going to have to interoperate with existing systems that we have here for descriptive cataloging purposes, et cetera, et cetera. But we realize that these integration points can sometimes be extremely difficult to do. So we're going to try some out. We're going to use some very specific collections, run them through the system, see what the catches are for actually being able to integrate something like EaaSI with our existing catalog system. So yeah, we don't have a lot of questions at this point, not a lot of answers, but we realize this is an ongoing challenge.
Yeah.
Ongoing challenge feels like a philosophical, our bit of our motto. But
yeah, but it's really cool. I mean, we're really
yeah,
making progress here. I mean, I really want to stress to folks that yeah, there's a lot of challenges that are articulated in this, but at the same time, we're getting there. We're making progress, and yeah,
coming up with
there's
tools
hope.
to address them as we improve the tools will be the ongoing challenge. Yeah. This is really great. And I see we're starting to get some people dropping out of the webinar. So I do want to sort of move into wrapping us up here. This has been an awesome discussion. So is Seth and Michael, are there any sort of like lingering points here from our discussion that you want to be sure to put in front of people before we start closing out?
I would just say that I think I just wrapped up a update to the data model, which was sorely needed as we move into actually developing the front end. And I will hope to post it through our OSF site, and we'll provide a link to that in any sort of follow-up posting about the webinar. And I'd be curious to hear feedback from anyone on the call in the community. You can tell me if I've put things like, the GPU cards IRQ setting in the right table, what have you. Like, these are the details that keep me up at night or keep me up late. So I welcome more eyes and more input. So please take a look.
Yes, thank you, Seth. Yeah, so everyone keep an eye out on the EaaSI OSF site. Keep an eye out on our project site on the SPIN, softwarepreservationnetwork.org, and our social media through Software Preservation Network. This has been fantastic, and be sure everyone to join us next month in October for our next and final, unfortunately for now, episode in the EaaSI webinar series. That's going to be entitled EaaSI Configuration Workflows. And we'll be joined in that call by Lauren Work from the University of Virginia, and I will be the EaaSI staff lead talking about my configuration work with the students here at Yale that time, and Jessica Meyerson will take over hosting for that. So thanks again to everyone in the chat for great questions. Thank you for joining us, and we will see you next time. Thanks, Seth. Thanks, Michael.
Thank you. Thanks, everyone.